Hey guys, we're the Gossipers, and my name's Lily. I was in charge of doing Mod 4, Mod 6, and implementing the passcode for our GUI.
Hi guys, my name is Omar. I was in charge of doing Mod 8 as well as the odd even, both the embedding and the recovery techniques. My reach function was the sound button.
Hi, I'm Ryan. I was in charge of making the expand and flatten functions, as well as the change digit techniques, and my reach was a reset button.
So we did the steganography project. The steganography is the process of encrypting a message video file into another message video file. And so without further ado, we're going to show you our GUI.
Through our file folder and opening up our Steg app. So here we have our little password pop-up window, and you need to insert 123. If you don't, you'll get an incorrect message. For example, 124. It'll be a sad face because you can't get in. So 123, password correct. We got to go into our GUI. And the first thing we're going to do is load our dog image.
Now that we have loaded the dog image, we can head over to the next window. Here we can see all the hidden images 1 through 10. Also, when we push on the button, we're able to hear the sound that I was able to create. If we want to embed a picture, let's say hidden image number 2, we select it and we head over to the next window as well. And let's say we want to use the embedding function mod for red. We click on it and then we do embed. Once we hear that sound, we know that the hidden image 2 was embedded into the dog picture.
Now is find the proper recovery method to recover the specific hidden image we chose that we embedded with mod for red. So I'll click recover mod for red, and then when I click show hidden image, it expands it back into RGB image, and it displays this picture here. Then if you click restart, the entire thing begins again. We can embed 3 images simultaneously within the dog image if they're on different RGB layers. So for instance, if I take an image 1 and choose the odd even red technique and embed it in there, then I can choose hidden image 2, put it in the odd even green technique and embed it in there. In image 3, I can put it in one of the blue techniques, change it to blue, and then I'll embed it in there, so that when I go to here, if I click recover odd even red, show hidden image, I get the first one we hid, recover odd even green, second one we hid, recover change digit blue, third one we hid. So the image the user selects is an RGB grayscale image of values from 0 black to 255 white. What we want to do is make a hidden image variable that's the same size as the hidden image, but with zeros corresponding to black and ones corresponding to white. So to do that, we use a nested for loop to access every variable. If the image was less than the arbitrary midpoint of 129 or equal to it, then the hidden image's value became 0. Otherwise, if it was greater than 129, it became 1. So now we have a hidden image that's the same size as what the user picked, with zeros and ones corresponding to black and white pixels. So I'm going to explain the change digit blue techniques. These access the RGB blue layer of the dog image and change the last digit in each of its pixels to 2 if it corresponds with the 1 in the flat image, or 3 if it corresponds to the 0 in the flat image. So we use a nested for loop again. We change the dog image to strings so that we can access the end and change it to 2 or 3. Then we change it back into numbers. And then for recovery, all we have to do is check again if it's equal to 2, then change it to 1. Otherwise, it's going to be 3, so we change it to 0. So you can see how it recovers here only based on if it ends in 2. You can also see the second technique, which uses a similar method, except to change the values to 4 or 5. It recovers in a very similar way. So after you've done the recovery technique, you've gone back a 400 by 400 matrix of ones and zeros that's exactly like hidden image from the dog image. So in order to display that in the GUI, you have to convert it back to an RGB image. So what this just does is it sets the each of the RGB layers equal to 255 if the recovered matrix is 1. Otherwise, it's set equal to 0 for black.
Now I will be showing you the odd even as well as the mod 8 code parts for the project. I will only be going over the red layer because the green is essentially the same thing. It's just that we're changing this digit to a 2. So for the odd even red embedding, we create a function using if-else statements. So over here, we define the normal image red2 to be equal to the mread dog image. And then we head over to this part where we're utilizing logical statements comparing the flattened image and setting it equal to 1, and the mod function saying that the normal image red2 equals to 0. So if that's the case, then we're going to subtract 1 to make it odd. Else if, we'll be looking at another condition where the flattened image could be equal to 0 and the mod could be equal to 1. Therefore, we'll be subtracting 1 as well in order to make it even.
Mod 4, we're going to assign our normal image to the dog image using else-if statements and logical statements. This method is based off the remainders given from dividing 4, whether it be 0, 1, 2, or 3. This tells us that if it's odd or even, and then switch it to be vice versa. We also had to set our pixels to be greater than or equal to 250 to the 250 pixels in the dog image. This also sets the pixels less than or equal to 5, which is also equal to the 5 in the dog image. Same goes for mod 6, but we now have remainders from 0 to 5, but still the same method, where if the pixel is even, we add 1 to make it odd, and if it is odd, we add 1 to make it even.
For the mod 8 red embedding technique, we used if-else statements as well, but in order for this to work, we had to create our own function called mod_dog. In the dog image, we can't have pixels that are equal to 0 or 255 because it would mess up the addition process. Therefore, we have to create this function to account for the condition and be able to successfully recover the image. So this if-else statements basically combines logical statements, and it's looking at the mod 8 and all its possible remainders, which are 0 through 7, and combining them to the flattened image, which could be 1 or 0. So these statements over here could mean that if the pixel is even, then we're going to add 1 to make it odd. Otherwise, if the pixel is odd, we're going to add 1 to make it even. So it's just basically taking whatever it's odd and we're going to switch it to even, and whatever it's even, switch it to odd. Now, in order to recover the image that we have embedded for mod 8, we are basically, and again, using an if-else statement, and we're going to look at the mods of 8 and their possibilities from 0 through 7. And if it's 2, 0, 4, 6, that means it's even, right? So we're just going to set the recover image equal to 0 to make that even pixel black. Else if it's 1, 3, 5, 7, that means that we're dealing with the odd pixel. So we're gonna set the recover image equal to 1 to make that pixel white. For this part of the video, we just wanted to quickly show that all the 10 hidden images can be embedded into the dog image using any function that we have available.